All right, so I'm going to toss out a little soft ball, a little easy pitch. Hopefully, this is going to be like, oh, come on, Mr. Server, that's just too easy. And say, what are the horizontal asymptotes, vertical asymptotes, domain, and if there is a hole, where is it? I'm going to pause for a second while you give that a try. All right, first up, you should have factored it. Hopefully you have already into x plus 5 and x minus 5. Because if you can factor it, you should. And on the bottom, we have x plus 5 and x minus 7. And then that cancels that. And then, okay, what did that make? A hole. A hole at negative 5. Negative 5, comma, what? Well, I really write out the resulting function first. This is the function I have when it's all done. I just have to remember, by the way, that 5 has an issue. If I just think this is my function, I'm deceiving myself. It's the simplified function, but it's missing the fact that there was a hole here. All right, so that has a hole when I put in negative 5. I put in negative 5, and I get negative 10 over negative 12. Negatives cancel, 10 twelfths. Could you do even better by reducing it to 5/6? Yes, you could. Raise your hand if you had that right. Awesome. Now, I think we've moved to the point where most people can do that hole pretty easily, but can you do the vertical asymptotes? That's the question. A lot of people know the Bob rules for the horizontal asymptotes, but they haven't figured out where you get the verticals from. Would you please write down what you think the vertical asymptotes are? Pause for a second and give that a try. Okay, I'm going kind of fast because we have a lot of things to cover. If you look down here, that's the key to both the holes and the asymptotes. Those things, like negative 5 and positive 7, will crash my function. They're either asymptotes or holes. I think we've already established that the negative 5 was a hole. So then, what's the other thing? And if it's not a hole, what is it? It's an asymptote. And what is the asymptote at? X equals. And if this is a horizontal, it would be y equals. If it's a vertical, it would be x equals. I've given you those dumb little names, horizontal and vertical, to help remind you of that. Final answer, x equals 7. And there's only one of them. And I said multiple just to try to make sure you didn't think that this was also an asymptote. It's not. The x plus 5 makes a hole. And then last is the horizontals. Is this bigger on bottom, bigger on top, or same on both? Interesting. I had one person say same on both. I heard one person say bigger on bottom. Does somebody want to say bigger on top just so we can round it out? We can have all the answers out there. All right, think carefully before you raise your hand. Raise your hand if you think this one is the same on both. You are correct. Because if I multiply the bottom out, it would have an x squared in it. That's why they're the same on both. This has a degree of 2, and this, if I multiplied it out, would have an x squared degree of 2. Therefore, it's a ratio. A ratio of what? The lead coefficient numbers. They both happen to be 1s, so this would just be y equals 1. And the last thing is the domain. A lot of people look at this and say, oh, so the only thing it can't be is 7. False. There's 2 things it can't be. You're right, it can't be 7. But what else can't it be? Come on, what can't this function eat or it will die? Yes, negative 5. So if the negative 5 is included, and I shade this all in, I know some of you don't like to do it this way. You want to do it to the infinity way, it's totally fine. Then you're going to have a lot more keystrokes, so to speak. You'd have to write negative infinity to negative 5, parentheses, union, parentheses, negative 5 to 7, parentheses, union, parentheses, 7 to infinity. And I'm okay with that, but I think this is easier, and I will accept it. In pre-calc, we usually have this answer, but we sometimes allow this answer. They're both different ways to write it, different notations. One's called interval notation, parentheses, and one's called a number line notation. All right. That was a pretty easy one, honestly. This one's going to have a twist. Wait. Pause for a second. Let me give that one a try. Here we go. Verticals. They come from down here unless either one of them is a whole. Which one's the whole? Neither one of them is a whole. So this is none. Then which one's the vertical asymptote? Well, they're either one or the other. So both of these are vertical asymptotes. That one's easy to say. Oh, so it's -6. True. But this one's tougher. As long as you understand this is really 8x minus 7 equals 0, that's the key. You got to like set a little equation up. 8x equals 7, x equals 7/8. How many of you had 7/8? That's less than, that's not everybody, put it that way. You get that? I solved this little equation setting it equal to 0. Okay, horizontals. Is this a bigger on bottom, bigger on top? Same on both. Same on both, and so it's a ratio of the lead coefficients, and I usually say that was 1, but this one's 3/8. That's what that means to take the ratio of the lead coefficient numbers. Raise your hand if you had 3/8. Okay, and last but not least, the domain. From -infinity until it doesn't work. What was the first number where it doesn't work? -6. And then -6 until, what's the next number where it doesn't work? 7/8. And then from 7/8 to infinity and beyond. Yeah, I know. Don't try to explain that to a little kid who likes Buzz Lightyear. All right. Any questions? A lot of common mistake here is to not have this one in there. It does crash your function, so it can't be allowed to be in the domain. So you got to make sure you exclude that by having it a parenthesis around it saying it can't be 7/8. All right, now let's go back to that problem I showed you originally. Write an equation for this one. Hint, some of these are bounces and snakes, and therefore you have to change your equation accordingly. Hint, I'll start with this. That's a good way to start. I'll pause for a second. Let me give this a try. You should have said that that one was squared because there was a bounce happening here. And I hope you can tell by the way I drew that one that that's a special one too. It's to the third. That is called a snake. When you've seen it before when you saw this one. Do you remember the x to the third function? It's like that. Okay. All right. Next one. Just a smidge more difficult. What's that equation? If you don't think, oh, that's not harder, that's actually easier, you're wrong. Yeah, somebody had to spill the beans back there. That part's easy. The fact that they're both squared is easy. What's easy to forget? There's a negative because it's going down on the right. All right. The lead coefficient of this needs to be negative because it's down on the right. All right. So what if I said something is down on the right and up on the left? What would you be able to say about the lead coefficient. What could you say about the lead coefficient? And then what could you say about its degree? I know some of you could like write me an equation that would work, like for instance that you might say, oh, I can write an equation like that, but that's not what I'm asking. I'm asking to tell me about the lead coefficient and tell me about the degree. As soon as I knew it was down on the right, I knew that the lead coefficient had to be negative. That part. Raise your hand if you had that part right. Awesome. Then what if it's up on the left? What does that tell me about this degree that would be right here? It's odd. You had a 50-50. All right. So the degree, think of it this way. These are different, and different goes with odd. Okay? All right. Let's do one more that's like that. Let's say it's up and up. What could you tell me about the degree? And what could you tell me about the lead coefficient? I notice I put those in different order, so be careful. Up on the right and up on the left. What's the degree? What's the lead coefficient? Well, since these are the same, that doesn't mean odd, it means even degree. The degree is even because they're the same. If they had been different, the degree would have been odd. And then the lead coefficient is that number in the front. Is it positive or negative? Because it's going up on the right, it's positive lead coefficient. How many of you had that one right? And be honest, I need to get a feeling for whether we need to practice this more. Okay. A couple of you need to practice. There's some of that on your homework. Now, one last reminder thing. Do you remember synthetic and long division? They're coming back. So here's a typical question. Do long division to factor this polynomial. I know some of you are like, but I like synthetic so much better. Honestly, in pre-calc, we use long division more. And when it comes to the ACT, long division is on the ACT, synthetic division is not. Okay, so if you're picking based on ACTs and next year, long division is more important than synthetic. I know synthetic's awesome, it's fast, and we'll do it too, but just trying to be a good guide for you, and it'd be really awful if, like your basketball coach told you that you needed to practice left-handed three-pointers because they were going to be worth a lot. Well, that would be a huge waste of your time. They're not worth anything. Well, actually, they're still worth 3 points, but they're really, really hard to do and get awesome at it, and so what? You're almost never going to use it. Although Larry Bird, who was one of the most famous and best basketball players ever, he could shoot right-handed or left-handed, and he would sometimes shoot left-handed three-pointers. Pretty amazing. He scored 60 points in one game once. He was just on fire. Okay. Hint. You should have started by seeing what to put here to make this times this equal 6x to the third. So I needed a 6x squared. Raise your hand if you started right. Awesome. If you forgot that, get back with the program here and start it over again and do it with me. 6x squared times x makes 6x to the third. And then you times it here. 6x squared times 2 makes 12x squared. Yay, it matched up. And in case you forgot, you're supposed to make these opposites of each other. In this case, they happen to both just drop out. But just so you know, you need these to be opposites, so you're adding straight down. In this case, they happen to both drop out. It means I can bring down 2x plus 4. And then I can say, what goes here? What times x would make 2x? Well, how about 2? 2 times x, 2x, 2 times the 2, 4. Draw a line, opposite, opposite, and it makes 0 remainder. Cool, it worked. What's the point? You've got it factored. And kid goes and does all of this right and still gets it marked wrong. It's cruel, but it happens all the time. 'Cause why? Did anybody even notice? Can anybody at least see it now? Yes? You can take the 2 out. There's a 2 here and here. So you needed to have it like this. You can put the 2 all the way in front or just in front of this little part. That's factored all the way. Okay. And then the roots of it. There's real and imaginary roots. The real ones are easy. They're the kind that are like this, and you just solve them and you get a simple answer like x equals -2. How about the imaginary roots? Imaginary roots, that's taking this and setting it equal to what? 0, and then solving it, and you will get an I in your answer. Would you please try that right now? Solve that. Your answer will have an I in it, or you're doing something wrong. Pausing while you try that. Okay. Looks like algebra to me. Square root, look at that, square root of a negative. That's why we have an I involved. I root 1/3. Last thing, because it's an absolute value, there's 2 answers. Positive I root 1/3 and negative I root 1/3. And yes, I would have accepted it if you had put a plus and minus in front of it. There's your imaginary answers. The last thing I want to give you a hint on. That should be easy for you to factor. 5x minus 1, 5x plus 1. Very good. That should also be easy for you to factor. I saw that on a retired ACT test just during break. Take a look at that one. I bet you could factor it if you use an I. If you can't, you wouldn't have got this right on the ACT. On the ACT, on average, we'll have 1 minute per question. Take 1 minute starting now. Try to figure out the answer. Did you get 5x and 5x? Did you get plus and minus? That should have been the easy part. And then it's the square root of 1, which is 1. And then that's the answer if this had been negative. So then what's the only difference? Throw in an I. Why does that matter? Because when you multiply it all out, at a strategic moment, that I times I will become I squared, and that makes a -1, which throws in an extra negative, which makes that middle positive. In other words, if I actually multiply this all the way out, that makes 25x squared. The outside and the inside just cancel because they're exact opposites. And then this times this makes -1I squared. And if you're smart enough to know what that means, it really means plus 1. Because I squared. is negative 1. And that leads us to our last thing. I to the 7th plus I to the 5th plus I squared. It all simplifies down beautifully. Your answer is just like I, or 3, or 3 plus I. Hint, I squared can be built into all of these. Like that I to the 7th, that's really I squared times I squared, etc. Simplify this all the way down. I'm going to pause while you try it. All right, so this one we had I to the 7th simplifying to negative I to the 5th simplifying to regular I, and I squared being negative 1. And these two cancel each other because they're opposites, so the answer was negative 1. That's all I got for you for today.